Hi guys, welcome to this tutorial. In this tutorial I'll be talking about how to implement naive-Bayes algorithm from scratch for categorical data. What I mean from categorical data is for a particular feature the values can come from a set of values. So say for humidity it can be only high or normal or low also. So there are only set of values which it can take. So this is categorical data. Now let's see what is naive-Bayes algorithm. What is it actually? But before that, let's see how our data is. Our data consists of 4 features and the final outcome. So 4 features are outlook or events. So outlook, temperature, humidity, windy. These are my 4 events or features. And based on that, I want my outcome is I want to go to play outside or no, yes or no. Okay, so this is how our data looks. So let's get back to what is naive-Bayes algorithm. So a simple the task is given set of events, we want to classify whether should I go for play or not, yes or no. Okay, so what does Bayes theorem says? Bayes theorem says posterior probability equal to likelihood into class prior divided by predict prior. So in probability terms, P of C given X. C given X means what is my probability of class or of outcome? Yes, given that my set of events are these, all features are these. So that is nothing but it is equal to P of X given C. That is given that I am going to play outside, these set of features has occurred, and into P of C or class prior, that is how many times my outcome, what is my prior probability or outcome probability. So for in this case you can see no or yes, there are 2 only and there are 14. Okay, there are 14 samples. Okay, so how many yes are there, no are there? 5. So my class prior probability will be like 5 by 14 and 9 by 14. Okay, and P of X is given. So for a particular feature, what is my probability of overcast? Say for outlook feature, what is my probability of overcast or rainy or sunny? So like 4 by 14, 5 by 14 and all. And P of X given C also, in this case I'll tell like given that my outcome is no, what is my probability that it is in outlook it was rainy. So that is nothing but P of rainy given no. Okay, I mean that was one example. So let's see one example considering what inputs. So I want to find probability that my class is yes or output is yes, given that the set of features are rainy, mild, normal, comma T. So these 4 are the features: rainy, mild, normal, comma T. Okay, so I want to find this probability. So for using this Bayes algorithm, it can be written as this: P probability of rainy, that is likelihood, rainy, mild, normal, T given S, into P of S, that is class prior, and probability of rainy, comma mild, comma normal, comma T, that is predictive prior. So now that was Bayes theorem. What is naive-Bayes algorithm is? Naive-Bayes algorithm assumes that these all 4 features are independent of each other. So my humidity doesn't depend on temperature. That is naive-Bayes theorem's assumptions that my features are independent of each other. And that's the naive part of this because it's not necessarily be true. So assuming that, we can write this P rainy, comma mild, comma normal, comma T. Assuming all 4 events are independent, we can simply multiply them. That is basic probability theorem. Similarly, this also we can write like this: P of rainy given S, because these 4 features are not dependent on each other. So we can write P of rainy given S, mild given S, normal given S. So, okay. So now what is rainy given as? I mean what it means is, given that my output is yes, so there are only 9 yes, right? 1, 2, 3, 4, 5, 6, 7, 9 yes. And how many rainy are there? 1 and 2 rainy are there. So P of rainy given yes is 2 by 9. Similarly, mild given yes is, how many mild are there? 1, 2, 3, 4. So 4 by 9. 4 by 9. Similarly, for all these we can put. And what is probability of yes is 9 by 14. Because there are 14 samples and there are 9 yes. And predictor prior is, say there are 5, we'll see. There are, see, 1, 2, 3, 4, 5 rainy are there. Rainy are there out of 14 samples for a particular, for outlook. So that is 5 by 14. Similarly, for mild there are 6 miles, 6 by 14 and all. And after doing all calculation, we are getting 0.43. Similarly, we'll find what is the probability with these same events. What is the probability that it can be no? And we can do the similar process and get that is 0.31. So this is 0.43 and this is 0.31. Note that it's sum doesn't necessarily has to be 1, okay? Because it's a conditional probability. Now this is larger than this, right? So we'll predict that yes, you should go outside or you can play. We'll predict a yes because it has higher posterior probability. Now what there's also something called as M estimate. So why we do that? Because there can be times where the P of x given C is 0 for sometimes, which will make the prediction 0. Say, for example, instead when no give, I mean we want to find the no, and here instead of rainy it is overcast. Okay, in Outlook it is overcast, but when we check in no, there are no overcast. So probability of overcast given no will be 0, which will make our whole this term as 0, which is not good most of the times. So what we are doing here is using a smoothing technique, Laplacian smoothing. For that, we are rewriting this equation as these part are same, but we are adding m into p and n, where p is the prior estimate, which we can usually generally take uniform. That is, for our case, our outcome can be only yes or no. Okay, so there are only 2 outcomes. So p will be 1 by 2 if we consider uniform distribution, and we also usually take m into p equal to 1. Okay, so this will make even if there is a overcast in this no, it will not make it 0. It will be like no given, I mean it will still be some probability and it won't be 0. Okay, so this is M estimate. Now we can proceed to our coding part. Yeah, so let's first import the libraries and load the data. We know how our data looks. We have 4 columns or 4 features and the output play, which is yes or no. So we'll convert them into X train or Y train, X or Y. So X is our input and Y is our what we want to predict. So what are the important features which are required to do this naive Bayes algorithm? Like we need likelihood, class prior probability, and predictor prior probability. Okay. So we will store all these values for each feature in a dictionary. Okay. So let's just first initialize the dictionary values as 0. As you can see, for class priors it is no, yes, and these are the initial values 0, such that, and we can update it later. Okay, so let's start. Okay, for featuring features, so we are having 4 features. For featuring features, and for feature, we need feature values in predict priors and likelihoods. We don't need in class priors, so nothing to update here. For feature in features, likelihoods of feature and predict priors of feature. So for each feature, I'm creating an empty dictionary again. So for Outlook, I have created an empty dictionary. here for for temperature empty dictionary. So for each feature an empty dictionary is being created. Now what I'm doing is for feat value in np.unique extreme feature. So for that particular feature, I'm using a for loop on the unique values. Say for Outlook, I have 3 unique values: overcast, rainy, and sunny. So for Outlook, I'll be running this for loop for 3 times. So predict priors, because I want to add overcast probability, rainy probability, and sunny probability. So for each features I want to add the predicted prior probability. Okay, so that's why this is being used. And dot update field, this is nothing but adding values in a dictionary, in an empty dictionary. So first overcast is being added, then rainy, then sunny. Okay. Now for outcome in np.unique white-rain does have yes or no, and we need a yes or no or these values in class priors and likelihoods. As you can see, we need given no what is the probability of overcast. So we need outcome values in class priors and likelihoods. Okay, so for outcome in np.unique white-rain, likelihoods of feature means Outlook. We have created an empty dictionary for Outlook. We'll add an entry such that feat val is overcast, rainy, or what was rainy and sunny, overcast, rainy, and sunny. Okay, so feat value is overcast, rainy, or sunny, and outcome is yes or no. So you can see overcast underscore no, overcast underscore yes, rainy underscore no, rainy underscore yes. So this is how we have initialized our likelihood dictionary, predict prior dictionary, and class prices. Here we are just adding yes or no. Okay. Updating. Update. What does dot update do? If that value is not there, then it will add. If it's already there, if a key is already there, it will just update that key pair, key value pair. Now we have these 3 dictionaries. Now let's fill these dictionaries. So first with prior class probabilities, that is probability of no and probability of yes. So it's simple. For outcome in np.train, we'll just count how many times we are getting no, and we'll divide by the training size. So it will count how many yes or no are there, and this will divide. Okay. So we are having no, which is 0.357, which is 5 by 14, and yes 0.64, which is 9 by 14. Okay. Now we'll update likelihood, our likelihood dictionary. So for feature in features, for every features we have to update. Okay, like overcast underscore no, like overcast underscore yes, rainy underscore no, rainy underscore yes, like that. Okay, so for feature in features, so for Outlook, for temperature, for humidity, for windy, and for outcome in np.unique, so for yes or no. Okay, so then outcome count is needed because as we have seen this, rainy underscore no, so give how many times no is being present in the data set is 5 times. So we are calculating that thing here. Then feat likelihood equal to xtrain of feature. Xtrain of feature means for that particular feature or column, and indirectly what this part is doing is taking all the samples for a part on the column of feature with the outcome as, with our ground truth as outcome, that is yes or no. Okay, and then it is dot index dot values to list, and then it will create a list according and with the values how many times they are repeating. That will be done by dot value counts. It will count how many times that is repeating, and then it will do for 2.it. So, and then I'm printing feat likelihood. So I'll explain. So I'll explain that as an example. Okay, for feature in feature, so we have 4 features: outlook, temp, humidity, windy. So for outlook, and then we have 2 outcomes, yes or no. So consider no. Okay, so outcome count is nothing but the count how many times no have occurred, which is 5. Now for each likelihood, I'll explain this term first. What this term is, like it's checking y train double equal to outcome. So for each samples which are having their outcome or play as no, we'll consider these all these values, these rainy, 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 sunny, sunny from outlook, and then we'll create a dictionary from it. Okay, so this is there, rainy is 3 times and sunny is 2 times. Now this is feet likelihood. Similarly for yes, it will be like for yes there are 4 overcast, 3 sunny and 2 rainy. Okay, so if we do this for each feature, we'll get this our likelihood dictionary. So you can see like rainy, this is for no. Okay, so rainy underscore no is 3 by 5 because there are 3 and total there are 5, 3 plus 2 5. So rainy underscore no is 0.6, sunny and sunny underscore is 2 by 5, which is 0.4. Okay, so this is our likelihood, my likelihood dictionary. Now for prior dictionary, that's predictor prior dictionary, that will be similar to this prior class. Okay, I mean we are just counting how many times they are present and dividing by the total samples. So you can see for feature in features, for each features we'll have to do that. For each features we'll have to calculate how many times, like what element is appeared how many times and create a probability out of it. So for feature in features, feature values is x train of feature, which is say outlook dot value counts to dict. So it's just doing this rainy, sunny, overcast and having these values how many times they have occurred. And then what we are doing is we are updating our priors dictionary by count divided by train size. For count, for feet well which is rain and count is 5. For feet well rainy, count is 5. Feet well sunny, count is 5. Overcast, count 5. And we'll divide by the train size. So 5 by 14, 5 by 14 and 4 by 14 is our probabilities. Predictor priors. So this is how we have got our predictor prior dictionary. Okay. Now we have all the values which we are required. These 3 things. Yes. Now let's calculate. Let's see for a particular input. Let's try to predict what can be the output. So consider a query. Okay. I'm having rainy, mild, normal T. Similar to what we have done here. Rainy, mild, normal T. Okay. And for query in Q, we have right now only one, just for example. Okay. It can be for test, for X in test, where there can be many samples in it. So props outcome is nothing but a dictionary which will contain the probability of no given a query and probability of yes given a query. Okay. For outcome in np.unique, so for each outcome we'll have to predict the probability or find the probability, right? So that's for loop for that. Here we have calculated for yes and no, right? So this for loop is for that. Now prior probability is nothing but class priors of outcome, which was this. Likelihood and evidence is initialized as 1 because we are just simply going to multiply all these. So it's just like 1 into. So that's fine. That's just to initialize. Now for feet well in zip features query. In zip features query, so what are features are those 4 values? I mean those 4 columns: outlook, temp, humidity, windy, and query. Yeah, so these 4 are query. So first feet will be outlook and rainy. Second feet will be temp and mild, and similarly. Okay. So now we are just going to multiply all the likelihoods. So what we'll do is from the dictionary we are extracting rainy given. What is the outcome for rainy given? No. So likelihood feet it will go for outlook, and then it will find for this. So rainy given no is 0.6. Feet well, rainy given outcome no. Similarly for evidence, we'll use this predict priors. Feet is outlook. In outlook dictionary, we'll among these three, our query is of rainy, so we'll extract this and multiply. Similarly, we'll do for mild, normal, and T, and then we'll get this part and this part, likelihood and predict prior probability. Okay. Now we'll have to multiply it by prior and M estimate if you want to consider M estimate. So likelihood into prior, which is this no yes, plus MP, which I have mentioned like predict price, and I have put 0 0, and depending upon the task we can change it as the required, and divide by evidence. Evidence is predict price. So here we calculated our posterior probability, and we have updated in our props outcome dictionary. So you can see this dictionary contains no as 0.3136 and this 0.3017. Similarly to what we got 0.3 and 0.31. Okay, and we'll predict the result whichever among these is having higher probability. So we'll predict yes. So that was the simple Bayes algorithm implemented in Python for categorical data. If you have any doubts, you can comment in the video link, and I'll post the GitHub link also. You can check that code in there. So until next video, take care, stay safe, be happy. Bye.